Hello everyone, welcome back. Today I'm going to talk about the water sort game. So what does the water sort game look like? So here I've pulled it up. As you can see, there's a couple tubes and several colors. In this case, there are 4 tubes and 2 colors. So the number of colors is equal to the number of tubes minus 2. And the goal of this game is to complete the tube so that the tube contains water of only one color. And once you complete it, so I can pour this one into here, that one is marked as completed. And then you have to do the rest of them. And the game ends when all of the, at least the puzzle, the current level ends when you have successfully filled in all of them with, so basically at the end of the puzzle, right, you're going to have n minus 2. So if n is the number of tubes, you're going to have n minus 2 complete tubes, all with liquid of only one color. And another thing, I'm not actually going to be solving the puzzle, but just to the actual game, you can only pour liquid from, first of all, you can't overflow liquid, and you cannot pour liquid into a tube that already has a different color liquid in it. So they start out like mixed up. So here, let me show you. I'm sure in the next level, it'll show me. Wow, that's a lot. Press continue. So in the next level, you can see they actually start out mixed, right? So I'm going to pour the cyan liquid into this one, but I can't pour the cyan liquid back in. So you see they start out mixed, but you can't mix them. You can't mix them once you've like moved them out. Does that make sense? So the task that I wanted to do is I did want to solve it, but the first thing in order to do that is I wanted to generate all possibilities for water sorting in this game. So how have I done that? So as you can see, in each tube you have like 4 volumes. So I mean here it's 2, here it's 2 of cyan, 2 lime, and then 2 lime, 2 lime, 2 cyan, and then 2 cyan here. Does that make sense? So there can be, there's 4 volumes, cubes, or whatever, 4 things in there. So if there were more colors, you could have red, orange, blue, green, or you could have red, blue, green, whatever. You get it. So I wanted to generate the total number of possibilities for all these test tubes. So let's take a look at how I did that. So let me first, so basically color 0, let's just say it's color A. So yeah, color 0 is A. Then we have color 1 is B. And then color 2 is C, for example. So how many test tubes? If we have 3 colors, we have 5 test tubes. So let me draw the tubes. So here we have 1, 2, 3, 4, 5. And then we have, like, for example, A, B, C. And then we have C, B, A, C. And then we have B. And we have a here, and then a B and a C. So you can see each color appeared 4 times. Obviously it has to appear 4 times because if we want to end with a sorted outcome, then it should look like this, right? B, 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 like this. And when you end the puzzle, you should have 2 tubes left blank. They might not be the original tubes that were in the blank in the middle, in the beginning, but at the end of the puzzle, you will have 2 empty ones that you will have used, of course, during the puzzle. Because from here you can't do anything. Probably the first step is to pour C into 1. Probably a good idea, and then take out A, B. So this is like, when there's 3, it's really easy to solve. But as it gets more, as you get more, it's difficult to solve. And one thing to note here also is that there's no guarantee for a solution. There is no guaranteed solution. And the other thing to note is that it's NP complete, the problem. So, even if there's no like efficient way to solve it, right? It's equal, at least from what I can remember, it's equal to the class of problems that are NP complete, which none of them have polynomial time solutions, I guess. I think that's right. So, how did I generate these? So two things that I was worried about when generating this, right? Number one, right? So I didn't want to double count. Let me just write, didn't want to double count. So let's just say we have one possibility here, and then the way we transform it is we swap two colors. And then we end up with another possibility. I didn't want to count this possibility, right? Because the colors, they don't make any sense on their own. It just, you know, we don't really care about the order of the colors. What we care is about the test tubes. And I guess the other thing that I care about is test tubes, right? Wait, I wonder if I even did this second. Test tubes can come in any order. Can come in any order. I wonder, did I? I'm not sure I did this the second condition. We'll have to take a look and see. So basically then the way I formulated this problem, I wasn't sure how to do. I mean, obviously you have to do some sort of like choosing. So you have 32. So in the case of, let's just say 3 colors, you have 12 possibilities, and out of them, you take 4 and put your first color in there. I mean, this is what I was thinking, right? You put your first color in there, and then out of the remaining 8, you choose another 4. So let's just say, let me say 12 choose 4. Let me redraw it. 12 choose 4. This generates a bunch of possibilities. And then for each of these possibilities, we do 8 choose 4, like this, you know, for where the second color can go. And then there's only one place where the third color can go. So in this case, it's pretty easy. Yeah, but this does not satisfy the first. It just doesn't. Because you can swap, you know, 2 colors. It's like, imagine I'm looking at this, A, B, 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 C, 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 right? So if I swap these 2 colors, B, 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 and then do A, and C, 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 then, so here I have swapped them, then they would, so let's just say in this possibility, I would have picked like A, and in this possibility, I would have put the A's into the second test tube instead. Second test tube. And then I would have put the B's in the first. Basically, I would have, according to this, I would have definitely generated both of these and counted them as their own possibility. But I don't want to do that because in the game or in the problem statement, these 2 possibilities are the same. You know, doesn't the order of the tubes doesn't matter at all. So how did I fix this? So the way I fixed this is I forced, so when I start with A, I force that the first color in the first test tube has to be an A. Okay. And then I pick spots for the 3 remaining A's. So I have 3 A's here. And then I can put them, so here's my list of 12. I can put them anywhere I want. Now, where do I put my B's? So, I mean, I have to do the B's for every single possibility that I came up with here for putting the A's. I don't know if it makes sense. So let's just say I put an A here, and I put all 4 A's like this. Then I have 8 positions left. Then, I mean, there's lots of places where I can put the B's now, right? Or let's say instead I have AA, and then like this, and then like this, and then an AA here. There's still lots of places where I can put the B, right? I can put it here, here. So basically, I've left a bunch of blanks open, and now I need to fill them with all the possibilities. A choose 4, right, for B. I guess then the other way I have, so then how did I solve problem 1? So I made it so that A always has to be the first one. So I only have 3 A's to put. So A always has to appear in the first one, and then the other 3 A's can go anywhere. So now when I do B's, the B has to go in the first available open spot. Why? Because the color has to go in here. And if I put C in here, I don't want to double count the time when I put C and then, like, let's just say I picked, let's just say I put a B here, B here, B here, and B here, okay? And then the remaining C's are C, 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 right? So now if I instead allowed myself to put C in this spot, then I would have gotten A, C, like I'm looking at this possibility now, A, B, B. So basically I've swapped B and C, which I don't want to count this possibility, right? B, B, and then C, B, C, B. But if we allow C to go in here, this is totally something I would generate. Therefore, the first open spot has to, I just have to put B into there. And this should hopefully remove the times when we swap 2 things, because only one of them can appear here. However, I don't think this might not actually, I might not actually have done this correctly. So let's just see. So if I do AB, AB, AC, AC, BC, BC. So then I wonder, what about this possibility? AB, AB, BC, BC, AC, AC. So here I have just swap these 2 test tubes, right? So is this something that my formulation could have generated? Nothing wrong that I see here. Then we put the A's here, and so we put the A's here, and then yeah, I don't see why I could not have generated both of these. This seems totally reasonable. And in this case, these test tubes wouldn't have, you know, it wouldn't have. So it looks like I need to reformulate my solution, because this isn't. I didn't. These are the 2 goals that I set out to fulfill, and it's possible that I didn't end up. Well, this one might be. This one might be fine, but this one I don't think I managed to fulfill. So, yeah. So the numbers I got, I guess, with my incorrect solution are 1 when there's 4 test tubes and 2 colors. There's actually when there's 3 test tubes, there's only 1 color, so there's only one way to do this. But then when there's 4 test tubes and 2 colors, then there's 35. And then when there's 5 test tubes and 3 colors, then it's something like 2,675,000 or something. And then 6 test tubes is way more than 10 million. But I'm gonna have to revise this. So hope you enjoyed. Thank you very much. See you next time.